instead of doing this Math 111 test 4 review, one thing I'm going to do before we get started on this review is say the best way to study for a test is always to practice these types of problems. So go over my review, go over your teacher's review, and hopefully if you do those a few times each, you should be well off enough that you will do really well on the test. So otherwise, let's go ahead and get started. Okay, the very first problem says consider this following expression, and they give us an expression that has 3 terms. Now, if you look here, none of these terms are the same, meaning that you do not have more than one x squared term. This one, you don't have more than one x or more than one constant or number term here, okay? Because of that, you have 3 distinct terms, 1, 2, 3. That makes it a trinomial. Now, one of the tricks that your teachers might try to do on the test is do something like 2x squared plus 3x squared, and then say, what's that? Well, because you can add those to get 5x squared, that is not a binomial. This original one here is not a binomial. That is a monomial, because it ends up just being 1. So please be careful. I've seen a lot of students get messed up on those types of problems before. I just wanted to let you know about that, because I don't want you to accidentally take that one if that's an answer. Now the next thing says determine the degree and the leading coefficient. Well, the degree is going to be the highest exponent. In this case, the degree, d, is equal to 2. And the leading coefficient is just the number with the sign, meaning if it was a negative or a minus 5x squared, it would be a minus, okay? The coefficient of the polynomial, so it would just be it would be 5 by itself. Not 5x squared, not 5x, just 5. Just whatever this number here is. That's the leading coefficient, okay? Now, this next one says, evaluate the given polynomial at y equals 4. We're just going to take 4 and we're just going to plug it in everywhere we see y. Whoops, we don't see y there at all. So you're going to get negative 2 times 4 squared plus 7 times 4 minus 5. Now, 4 squared is 16. Do this right here, 7 times 4, which is 28, minus 5. So minus 2 times 16 is negative 32, plus 28, minus 5. Minus 32 plus 28, you want to do left to right first, okay? Ends up giving you minus 4, and then bring down your minus 5. We're going to be adding those 2 negatives to get minus 9 as the final answer to this problem. Okay. Now, moving along to the next one. The next one says multiply the binomials using FOIL. Well, we know FOIL stands for first, outer, inner, last. That's what the letter stands for. Let's go ahead and do that. So first, those and those. X and x gives me x squared. Our outers, x and 2, it gives me a plus 2x. My inners, 8 and x, plus 8. And my last, 8 and 2, plus 16. Now, I can combine these 2 terms because they're both x terms. So 2x and 8x ends up giving me 10x. I'm going to write this out as my final answer, x squared plus 10x plus 16. I cannot add or subtract anything more in this problem. I am finished. And number 4, this one that I put on this review is a lot harder than the one that you would probably have on your test or your review as well. But the best way to do these whenever you're dividing something like, polynomial like this by a monomial is to break them up. You do them each individually. So watch what I'm doing here. I'm literally writing this bottom one over all the top ones, breaking them up, separating them out because it's a lot easier to do it individually like this. Okay. Now the first one, you want to go here and you want to say, how many times does 3 go into 9? 3 times. How many times does x cubed go into x to the 4th? Or, if you're thinking 4 minus 3, with the x term, subtracting them, you're left with x to the 1. Okay, so you can write the 1, you don't have to. I can write it, or I don't have to write it, alright? Now this next one, I need to take this minus, bring it down. 3 goes into 6 twice. Now look here. If I subtract those, I get x to the negative 1, okay? But what happens when you get x to the negative 1? Let's take a little sidebar here. X to the negative 1. we always want to write these as positive exponents. So x to the negative 1 is the same as 1 over x. Okay, but I have this 2 here. How do I do that? So what we're going to end up having to do is just stick the 2 in the top. And then this, what I just wrote, is how this would be written in our final answer. So I'm going to go ahead and write this part because that's going to be in our final answer. Okay? Now, this next one, how many times does 3 go into 9? Well, 3 times plus sign. What happens to the x's? They cancel. They're the same power. And then last but not least, 3 goes into 9 again 3 times. But look here. Are there any other x cubes in the top or anywhere else? No. So this is again a fraction. Written like that. Okay? The x cubes will stay in the bottom. They will not go to the top. They will not become negative. They will not go to the side or anything. So to write my final answer with positive exponents, this one right here, circle it, is how it would look. So what we need to do is, if it's a negative exponent, like we were looking at here, it needs to go in the bottom, okay? If it's in the bottom, leave it in the bottom, all right? Another way to think of it is, whenever we were doing this one, right here, the bigger exponent was in the bottom. Where's our answer? In the bottom. So you have to think to yourself, if it's bigger in the bottom, it stays in the bottom. Moving along. This next one is asking us to simplify this using properties of exponents. Well, the first thing we need to talk about is, what is anything to the 0 power? Anything to the 0 power, it doesn't matter if it's a billion to the 0 power, 1 to the 0 power, or a bunch of stuff in parentheses here, like this is the 0 power, is always 1. Now, this stuff to the 0 power is just including stuff in this red box. Stuff in parentheses raised to the 0 power. The 3 is not included. It's not 3 to the 0 power. So this is the parentheses. This is the 3. What's 3 times 1? 3 is your final answer. Okay? So just know anything to 0 power is 1, not 0. So the next one's asking me to FOIL and combine like terms. Let's go ahead and do that. So we'll get using FOIL. I got my first. 3x and 2x gives me 6x squared. I got my outers. 3x and 2, 6x. I got my inners, 8x, and I got my last, 8. Now the like terms that I can combine are in the middle. So I get 6x squared plus 14x plus 8. There's nothing else I can do to finish this problem, so I'm going to leave it just like that. Okay, this one here says, perform an operation by removing the parentheses and combining like terms. The only time you're really ever going to have a problem with removing the parentheses is whenever this is a minus sign. This is a plus sign, so I can just go ahead and remove those parentheses now and write everything exactly how you see it. So I'm just taking out the parentheses, writing everything exactly how it is. Now, my like terms, because I'm just adding and subtracting here, those two are the same, because they both have an x squared. So minus 7x squared and minus 3x squared put together gives me minus 10x squared. And now I'm done with it. Now I have minus 4 and plus 3, which when I combine them end up giving me minus 1. I can't combine those any further, so at that point I'm finished. Look at the next one. Okay, this next one is saying write 46,000 in scientific notation. So, how to write stuff in scientific notation? You want to take the number, and if it's a positive number, if it's a large number, if it's not a little decimal, all right, you're going to start at the right side here, and you're going to go over and stop whenever you get right before the last number. Okay, so 1, twice, 3 times, 4 times. I stop there. I stop right before I get to the last number, so stop right there. Okay? Now, I did it 4 times. Right? My number now is a decimal, 4.6, because scientific notation is blah, blah, blah times 10 to some kind of power up here. This number here has to be a decimal, or, a number that's in between, it has to be like 1, so like, I'm going to say in between 1 and, like 9.9 or something. It's got to be less than 10, okay? Well, it could be like less or equal to 1. So, in this case, it's going to be less than 10. So you can have like 9.9, alright? You could have, you know, a bunch of decimals. You could have like 4.278 like this. That's okay. But you can't have 11 or 23. It's got to be a number in between 1 and less than 10. So this is 4.6. Any numbers after the decimal that are not 0 get counted here, okay? Times 10 to the 4th power. Where did the 4 come from? I moved it over 4 times. That's where that came from. And that's how we write it in scientific notation. I'm going to stop here and finish out the rest of this in a new video.